Chapter 9, the review questions, number 2, true or false. If the correlation coefficient is negative 0.8, below average values of the dependent variable are associated with below average values of the independent variable. First off, which is which? Dependent is So which variable depends on which? Usually, we put the independent variable on x. X can be anything, but y depends on what x is. Now, there's a little ambiguity there, but that's just how we're going to describe things. So, in general, x is independent and y is dependent. So, if the correlation coefficient is negative 0.8 and you are below average on the y, then you are probably also below average on the x. True or false? Well, let's look. What does this graph look like? It's a negative, what shape? Frisbee. So, here is the point of averages. If you are below average on the y-axis, then you are also below average on the x-axis. False. The people in here are below average on the y, but most of them are above average on the x because of the negative correlation. So negative means as one goes up, the other goes down. So in a positive correlation, this problem would have been true, but because it's a negative correlation, it's false. And there are no answers in the back, so you can't prove me wrong. B, if y is usually less than x, the correlation coefficient between x and y will be negative. So if the y values are usually less than the x values. So let's look at this one. And maybe we'll just put some numbers on here. 1, 2, 3. 3. So this is the point 1, 3. This would be the point 2, 2. And this would be the point 3, 1. If the y values are usually less than the x values, then the correlation will be negative. Well, in this case, what do you notice? We're a little bit all over the place. The first one, the y is bigger. The second one, they're equal. The third one, the x is bigger. But what if I did height and weight? So if I did height and weight, and this was everywhere from, I don't know, 60 inches to 80 inches, and this was everywhere from 120 pounds to 300 pounds. What do you notice? So every single y value is bigger than every single x value. So what do you think the answer is to the problem? False, because the y's being bigger than the x's doesn't really have anything to do with the graph. It just has to do with the units you're measuring it in. Right? If I graphed ACT score on the y-axis and IQ on the x-axis, every single x value is going to be bigger than every single y value. So you can't determine slope just by knowing that the y's are bigger than the x's or the other way around. Okay, because they might be two totally different units. All right. 5. A number is missing in each of the data sets below. Fill in the blank to make r equal to 1. If that's not possible, say why not. So A is 1, 1, 2, 3, 2, 3, 4. What? Okay, so 1, 1, 2, 3, 2, 3, 4, what? That number has to have what quality? In order to make a list have a correlation of 1, what has to happen with all the points? What's that? No, it's not the slope. If I tell you the correlation coefficient is 1, what do you know about the graph? It's a straight line. All of the points are in a straight line. So we need to find the y value that makes that point in line with the other points. Well, what's the slope? When I jumped from 1 to 2, what was the slope? Plus 2. So when I jump from here to here, what do I need to put there? A number that is how much bigger? Not 2. It's got to be 4 bigger because we skipped 3, right? It would be 1, 1, 2, 3, 3, 5, 4, 7. But this number's not there. The slope is 2, so this needs to be a 7. Now, the other way you can look at that is to graph 1, 1, 2, 3, and then 3, 4. You draw that line, and you see that's a terrible line, but whatever. Sorry. Right there. So there's 1, 1, 2, 3, and then 4, 7. Does that make sense? Hope so. B. So we have the point 1, 1, the point 2, 3, the point 3, 4, and the point 4 what? What number do we need to put in the y value to match 4? Not 5. Not 6. It's not possible. Why is it not possible? So 1, 1, 2, 3. That has a slope of 2. Okay? And then if we go from 2, 3 to 3, 4, that has a slope of 1. So those 3 points are not in a straight line. You have this one, and then you go up 2 over 1, and then you go up 1 over 1, and those 3 points are not in a straight line, which means they already have a correlation coefficient that's less than 1, and adding another number to that list will not raise it up to 1. You could make the correlation coefficient bigger or smaller, but you cannot make it 1 if it's already below 1. Okay, number 6. A computer program prints out R for the 2 data sets shown below. Is the program working correctly? Yes or no? So the first one, 1, 2, 2, 1, 3, 4, 4, 3, 5, 7, 6, 5, 7, 6. Maybe let's do this. Let me display it out. All right, so stat. Let me put the numbers in. Okay, so 1, 2, all the way to 7. 3, 4, 6, 7. Okay. 2, 1, 4, 3, 7, 5, 6. All right, I'm going to go in my window. I'm going to go from 0 to 10 on my X. And I will, not plus, that's definitely not what I meant. Counting by ones, and then from 0 to 10 on my Ys, and then I need to turn on my plot. So I turn on plot 1, I graph the scatter plot. Could that have a correlation coefficient of 0.82? positive, kind of a wide frisbee look. 0.82 sounds perfectly reasonable. All right. Now, all right. I do have a y value at 10. So I'm going to go into my window and extend my y's just a little bit so I can see that dot. Could that have a correlation coefficient of 0.76? Oh, looks good to me. Maybe that's, I don't know, is that, why don't we ask it? Let's find out what it is. What do you notice? That correlation is higher than the one they gave us. So what they're saying is that looks too much like a football to be or too much like a frisbee to be 0.76. A football would be more egg-shaped than this one. Or 0.76 would be more egg-shaped. All right, and 7. Hiram Johnson entered the California gubernatorial primaries. What does gubernatorial mean? Gubernatorial means governor primary. He was running to be a governor. Where gubernatorial came from, I have no idea, but that's the word. For each county, data are available to show the percentage of native-born Americans in that country, as well as the percentage of the vote for Johnson. A political scientist calculated the correlation between these percentages. It is 0.5. Is it a fair measure of the extent to which Johnson received native as opposed to immigrant support? So we measure the percentage of native-born Americans and the percentage of the people who vote for Johnson. The correlation is 0.5. Is it a fair measure, quote, that Johnson received native as opposed to immigrant support? What would you say? Correlation of 0.5. So what shape does 0.5 have? It's positive, so it's going up, and it's very egg-shaped. And on the x-axis, we have the number of people who, or sorry, we graph the people who were born in the United States, and on the y-axis, we have the people who voted for Johnson. Can we say that Johnson received native votes more than immigrant votes? What do you think? Is 0.5 a very good correlation? No, it's not. Definitely it's not. So with 0.5, you're not going to have an article that says, hey, the people that are born in the United States are more likely to vote for Johnson. Although that is true, but my question is, how do you put, this must be in each county. Okay. So a county that has a high percentage of native-born people will also have a high percentage of people who voted for Johnson. But can we say that it was the native people that voted for him instead of the not native people? No, this is not an experiment. It's just a study. So it's an observation. There we go. So let's say that this county had 75% of the people were born in the United States. Well, these people, this is the percent that voted for Johnson. It's all over the place. 0.5 is way off. And we can't say that it was the native people that voted for him, right? All we can say is there are a lot of native people in that county and a lot of people voted for Johnson. So over here, we have a low, maybe 10%. 10% of the people in that county voted for Johnson. Well, or sorry, 10% of the people are native. This is the group of people that voted for him. But we're not looking at individual people. We're looking at a county, which is ecological, and that just kind of messes everything up. So there certainly could be something else at work here. And once again, you can't prove me wrong. Number 8. For women aged 25 and older in the U.S. in 2005, the relationship between age and education level, which is years of schooling completed, can be summarized as follows. Age is an average of 50 with an SD of 16. Education level has an average of 13.2 with an SD of 3, and R is negative 0.2. True or false, and explain. As you get older, you become less educated. Because it's negative. It says, when we talk to older people, we find out they're less educated. Does that mean you become less educated as you age? No. What's happening? Why does this graph have a negative slope? And it's like that, right? So age and education. Why are these people who are older less educated? Education wasn't as not important, but as pressed on those kids when they were younger, right? Now you can go to college for anything you want. And more colleges are available. More and more seats are available. They just weren't available back then. A lot of our manufacturing and the hands-on jobs have moved overseas. And so now the younger you are, the more likely you are to spend more time in college. Okay? X does not cause Y. And Y doesn't cause X. In this case, it just happens to be a cultural thing. 50 years ago, fewer people went to college than go to college now. All right, number 10. In a study of 2005 math SAT scores, the Educational Testing Service computed the average score for each of the 51 states, that includes DC, and the percentages of the high school seniors in that state who took the test. The correlation between the two variables was equal to negative 0.84. So what that's saying is, so the average score of the 51 states and the percentage of the high school seniors in that state who took the test. So we have a Frisbee, and this is the SAT score, the average SAT score, and the percentage of people who took the test. Okay? True or false? Test scores tend to be lower in the states where a higher percentage of students take the test. Does it appear that a state that scores really high has a lower percentage of students who took the test? Yes, it appears that way. If true, how do you explain this? Why are the states with the highest scores also the states with the lowest participation? Right. Only kids that wanted to take the test and go to college took the test. Now, Utah mandated, what, 5 years ago, that every junior has to take the ACT. Guess what happened the first year that they took the ACT that way? The state score dropped a long way. Why? because a whole bunch of people who weren't planning on going to college took the ACT. And how did they score? They scored poorly. Why? They didn't care, or they weren't prepared because, or maybe they never intended to go to college. They had another profession in mind and they were putting their efforts in that area. Okay, B. In Connecticut, the average score was only 517, but in Iowa, the average was 608. True or false? The data show that on average, the schools in Iowa are doing a better job of teaching math than the schools in Connecticut. So the average score in Connecticut was 517, but the average score in Iowa was 608. Does that mean one state is doing a better job at teaching math than another? No. We don't know the participation levels. Maybe Connecticut makes everybody take the test and they have a lower score. And Iowa only tests the people who want to take the test, and that's why their score is higher. It might not have anything to do with the education. It might have more to do with the makeup of the students who took the test. And one thing you have to ask is, was the SAT, taking the SAT randomized? No. One state might require it. One state might make it optional. One state might push for kids to take the test. There are a lot of variables that could be part of that. All right, 11. As part of the study described in exercise 10, the Educational Testing Service computed the average verbal SAT score for each state as well as the average math SAT score for each state. The correlation between these 51 pairs of averages was 0.97. Would the correlation between the math SAT and the verbal SAT computed from the data on all the individuals who take the test be larger than 0.97, about 0.97, or less than 0.97? So we take all the states, we average out how well they did, and we graph those, and we get this. Nearly a straight line. If I broke those states up to include people instead of averages, what's going to happen to the R value? So I take this state right here. Let's say this is Utah. What do you think the scatter plot for Utah looks like? It's probably positive. Do you think it's going to look like a really thin frisbee? More football shape or egg shape? So we're going to break Utah up, and we're going to do that with all the other states. And now I have 51 scatter plots all put together. What happened to my R value? It dropped significantly. It was 0.97, and now that looks more like 0.7 because that's ecological. The original graph was ecological, and ecological often hides a lot of the variation. Number 12. Shown below is a scatter diagram for education levels. So years of schooling completed of husbands and wife in South Carolina from March 2005, the current population survey. The points make vertical and horizontal stripes. So on the first one, we have husband's education on the X, wife's education on the Y. And we do that, oh, I guess it's the same. I got you. So A, the points make vertical and horizontal stripes. Why is that? Why do those stripes exist? Why are the points evenly spaced? Right. So with school, most people end school at the end of the year. Right? But let's say that you did 13 years of regular schooling, and then you did 4.5 years of college. Are you going to run around and tell everybody I did 17.5 years of school? No, you're just going to say 18. Right? You're going to round up or down, 17. Okay? And then our ages, unless you're a kid that's under 2 and the mom is really proud and she says 17.5 months old. Everybody rounds their age to the nearest number. Usually we round down, right? If you're almost 50, right, next week, and somebody asks how old you are, what are you going to say? I'm 49, right? Not 49 and 51 50-seconds. So that's why they're spread out like that. B, there were 530 couples in the sample, and there is a dot for each one. But if you count the dots, you only count 104. Why? Yeah, there are a bunch of people who share the same dots. Now that gets a little messed up because we don't really know how strong the football is. Because some of those dots might contain 10, 20, 30, 40 people. And every one of the dots pulls on that football. So in a graph like this, it's kind of hard to estimate the correlation coefficient. Okay, see? 3 areas are shaded. Match the areas with the description. So 1, the shaded area contains the wives who have completed 16 years of schooling. Which graph is that? C. Wife completed more years of schooling than the husband. You see any of them where it shows the wives that have more schooling than the husbands? It's not there. I don't think it's there. Is it? No. 3. Husbands complete more than 16 years of schooling. That's B. Husbands complete 12 years of schooling, and wife completed fewer years of schooling than the husband. That's A. So let's figure out what would C look like. Or no, what would 2 look like? We have this football. Wives, husbands. How would I circle or shade the area where the wives have more schooling than the husband? Well, where will we find the line where wives have exactly the same amount of schooling as the husbands? Yeah, so 12, 12, 11, 11, 13, 13, 14, 14. Where are those points? They're on a 45-degree line, right? So everybody on this line is in the group of wives having exactly the same number of years of schooling as the husband. Okay, so where are the people where the wives have more schooling than the husband? What's that? The top part. Okay, so this person right here might be 15, comma 15. Husband 15, wife 15. But up here, that person is 15, comma 16, where the wife has 1 more year of schooling than the husband. So anybody above the 45-degree line is a couple where the wife has more schooling than the husband. That makes sense?